Hello everybody and welcome back. So in this next lesson we're going to take a quick look at VOPs and VEX and sort of how these two interact. So I'm sure if you've been using Houdini for a little while you will have used a VOP node at least. Even if you haven't done VEX coding, VOPs are highly useful, very powerful and quite common to be used in even basic contexts, right? And if you haven't, you're missing out. Very, very powerful. So essentially they're expert nodes at manipulating data, which, like I said in the last lesson, is all we're really doing with code. Okay, except a VOP is node based. Okay, unlike VEX where it's lines of code and expressions, these nodes themselves are essentially the expressions. Okay, and this is something a lot more that we're used to seeing in Houdini. Sure, it's a little bit different. It's not this kind of vertical node tree. It goes a bit more horizontal. The nodes are a little bit different, but still kind of works out to the same. Okay, so you can think of these VOP nodes, and I mean VOP is literally VEX operators. Okay, so these are this is VEX code basically, just visual. So you can think of this as a node-based logic system or a node-based maths system. I mean, I like to always talk about VOPs as being maths nodes essentially, because what you're doing is just manipulating the data. You're adding or setting or multiplying things and setting conditions. So it's maths and logic. Okay, and I would encourage anyone who is maybe struggling with VEX or has never done any coding at all to start with VOPs. Okay, so in this tutorial series we really are going to be diving into VEX rather than VOPs, so we're not going to spend much time on it, but if you are struggling, I would use VOPs as a starting point. Okay, one of the main reasons for this is just it's a lot simpler at first. It's similar to what we're used to seeing in Houdini. It's nodes, okay, and they have just a bunch of parameters on them. It's easier to understand the flow of data because you can actually visually see what is feeding into the next thing, the name of each input. Plugging things in rather than typing code and worrying about syntax is a lot easier at first, okay? And I'm going to stress that at first, right? So most people when they start in Houdini, and particularly if they haven't come from a coding background, are going to use VOPs but are going to avoid VEX. Okay, and that's quite natural and normal. So I'm sure most of you have probably done exactly the same thing. Okay, so not only is it visual, but also the fact that each node is essentially a little snippet of code. So you're not having to type, lines and lines and lines of code. Sometimes an example, it would be something like the turbulent noise. This is a function which then has loads of different inputs. It might take lines of code to write all of this type of stuff into it. Okay, or because it's got multiple different types of noise and one-dimensional 3D, so it's casting that noise. That could take lots of coding, but instead you're dropping down one node, right? And it's keeping it kind of visually just all in one node. It's easier for you to see, it's easier for you to learn at first, okay? And particularly when it comes to nodes that have a lot of input parameters like noise functions, or even the like texture nodes. Look at this, having to set all of these in your code can be quite daunting. So it's this that makes VOPs quite a good, I guess, starting point, a good gateway into learning how to code. And the reason I say learning how to code is because that's actually what you're doing. You may be doing it with nodes instead of text, but you're learning the logic, okay? You're running a comparison here with a greater than operation, okay? You're adding data or, setting just the y value of a vector, okay? Adding that to what? What are we adding it to? Oh, to our point position. Okay, so this is essentially step one of coding, is knowing just the logic and the maths, and then we're just learning the syntax, okay? And then we, over time, add the vocabulary, essentially. It's the number of expressions that we know how to code and how to fill it in, what arguments does it need, etc. But that all comes with time. This is step one, right? Now, although it is run on Vex, what you'll find is that the VOPs are a little bit less efficient than an actual Wrangle node, snippets. And that's because even though inside of here we are actually running an attribute VOP, but inside we're running just one snippet of code, okay? And this code that I've written here, so in this scene, I've created some weird random little function in both VOPs and Vex that do exactly the same thing. But you'll see that the Vex code is 4 lines. Okay, well, 6 lines total, but with the space in between. Okay, so we've got kind of 4 lines over here, and the VOPs for that exact same thing is quite a few more nodes, right? So it's you can see it's already less efficient. And if we right click and go under Vex and VOP options, you say View Vex Code. Now, this is a very cool trick to actually learning Vex code and transitioning from VOPs into Vex, is being able to view the code of VOPs that are already created or ones that you have created. So maybe you understand the logic, you set up a VOP, but now you want to see how to code that. Now, I would caution you, yes, this is a cool trick. Yes, it's nice to look at the code and learn from it, but do not take this as this is how you should write your Vex code. This is ridiculous. The level to which things are being set here. It's laid out in this way because it needs to take sort of every node into account, and it needs to have all these variables for, well, what if this is set with an expression, and what if this is set to uniform instead of float. It's essentially accounting for all of the options, which is why it is 253 lines of code as opposed to, there we go, what are we, 6 lines of code. Okay, so drastic difference. And sure, it processes the text quite quickly, so it's not that 253 versus 6 is literally that amount of lines, more like less efficient. It does process them pretty fast, and it depends what each actual line of code is doing. Some of the lines may be entirely redundant. Here there's a lot of spaces in between, and there's a lot of comments that are just here for visual purposes. But it's still doing a lot of things that it doesn't need to be doing. So ultimately what we can do is use this as a way to come in here and learn some things about the syntax of how to actually write Vex code. And then we can write it ourselves, but we can write only what we need. Okay? And in a small context like this, there will probably be no difference in computational power between running this VOP and this Wrangle. But put this on a massive piece of geometry, run it through like 100 million instances, and then you'll actually start noticing a difference. Okay, and it also matters what function we're running. If it's a very simple function, then maybe there's not that much difference between these two. But if the function you're running is something iterative, you're looping over each instance X amount of times, running proximity functions like PC opens, depends. If the more heavy things you're doing, then the heaviness of the attribute VOP will compound. Okay, and then every tiny sliver of saving that you can do inside of a Vex Wrangle is going to be exponentially greater. Okay, so essentially Vex code is all about efficiency. But then I would also like to say that you know, I did exactly what I mentioned to you. I started in Houdini using VOPs. For years, I used only VOPs. I kind of avoided Vex because it just seemed crazy. I was like, I don't understand this, and why do I need it? I can do everything I want inside of a VOP. Okay, but I worked with a guy who then knew his Vex and started seeing the power of it and the efficiency of it. So then I decided to start learning it. Okay, and now after a couple of years of using it every day, I can honestly say that it hasn't just become as easy as VOPs. It's honestly much easier. It is so logical the way the text is actually laid out, that sometimes this crazy mishmash of lines backwards and forwards and things being plugged in, it's very difficult to glance at this and know what this is doing. And yet you can glance at code like this, and maybe not yet if you're just getting started with Vex, but after a little bit of time, you'll find that this is actually infinitely easier to read, to see where you've gone wrong, and to work with. Okay, I mean, I actually think in code now, so I don't even, so like, here's another cool trick which you should start with, but like I'm saying, eventually you won't even use it, is you actually use VOPs not just for their code like this, not to do it and then view the code and see how it is, although it can be useful because sometimes there's certain nodes, but then the name of the function is very different to the actual name of the node. So it is good to use that. But what I started using it for when I was learning Vex was just to lay out the logic. So I would actually code a VOP like this, make sure it worked, and then because it was easy to drop down a node, test it, and then delete it, and plug things in a different way and get the right result. And then I would recode it, because I would go inside, look at the logic, and say, okay, what am I doing? Well, I'm setting point position. So here we go. I'm setting point position either to what it currently is. So in other words, I'm not doing anything to it, or I'm setting it to this value based on what? Based on it being on the X value of the point position being greater than a certain parameter. Okay. So then I start coding that. And that's that whole thing that I just explained, which seems quite complex and it's multiple nodes, is written in one line here, saying if the X value of the point position is greater than a threshold. Okay, so you see how much more efficient Vex is. But when you can't think this way, you use this to kind of lay out the logic. And it's almost like a mind map. It's kind of like drawing it out. Especially if you're a very visual person, then you'll think this way, lay it all out, and then when it works, you can use that same logic and apply it in Vex. And yes, at first, that is going to be quite cumbersome. It's going to be tempting to just use the VOP because, well, the VOP is already built and it already works. So why do we need to recode it? But just think of the savings in the long term. Okay? It is so much more efficient to write it this way. And once you know how to write it and you've done it a few times, then you won't even need the VOP. You'll just write it this way. Okay? And in addition to that, there are also things that you can only do in Wrangles, things where they haven't built a node that does that same function, or the node that does a similar function is so limited because it is closed, it is black box, it is kind of, this fit is only doing a certain function in a certain way. In the Wrangle, you can manipulate that function in so many more ways. So if you want something really custom, as soon as you start going above the basics, then the Wrangle is going to do it for you much more than the VOP is. Okay, but it takes time to transition, so I would encourage you to use both. Okay, especially if you're struggling. Okay, use the VOP, get the logic right, get the flow of data, and then go and write it. And I'm going to encourage you guys to do this almost as like an exercise routine, as a bit of homework. Okay, throughout the day or whatever project you're working on now, every time you write a VOP, write it in Vex as well. Okay, as we learn it, and you can also right click and view the code if you need to see a function that you don't know. but try to write it in Vex as well. And you may fail a few times, maybe it doesn't produce the same result, or you just get stuck and you're not sure how to do it, and that's fine. And you can ask on forums, or you can ask me or anyone else in the studio or at your college or whatever that maybe knows Vex a bit better and they can help you. But force yourself to actually try and write it in Vex. And then even if you scrap that and delete it and just keep using the VOP, but then the next time as you're building up your system, you need another VOP, you drop it down, you fill in the VOP, and then you write it in Vex as well. If you do that, you will learn Vex very, very quickly. Give it a month or two and you'll be writing nothing but Vex code, okay? I mean, honestly, it's reached the point where I now found it difficult to use a VOP, and I get really confused with all the lines because it's just so much easier to just have it written down. Okay, right, so I'll show you guys here just so you can see before we move on to the next lesson that these two do exactly the same thing. You see I've even exposed the same two parameters, and I've linked them so that as I manipulate the one, the other has the same thing, and you see here it's exactly the same. I'm just setting a threshold based on the X position of these points, and when they're over that threshold, then they transition into a sine wave along the Y axis, but there's a bit of a fall off of them, blending from that to unaltered, okay, and that fall off distance can be manipulated here, okay, and literally 253 lines or 6 lines of code. Okay, right, so we're going to start diving into actual coding in the next lesson. See you guys there.